Hello, everyone. Thank you for joining us in this webinar about the workflow for designing and detailing steel structures with CYPE 2023. Today, we are going to show you 4 of our programs, which, as I said, is a workflow between them, but you could also use them separately. First of all, my colleague David, who is there, is gonna show you portal frame generator, where he is gonna create a portal and then he's gonna send it to CYPE 3D to finish the project and analyze it. And then from there, he's gonna send it to BIMsteel and CYPE Connect to do the detailing and the steel connections. He's gonna design and analyze the connections, as well as extracting the sub-drawings. And in BIMsteel, you can extract the sub-drawings of everything else apart from the, and also the sub-drawings of the connections and the rest of the model. You can also extract the DSTVs and step files and IFC EM11, which is an IFC special for the steel part. Okay, so as I said, my colleague is David. He's a BIM architect and he works in the support department. And myself, I'm Marta Franca. And you have here, well, I'm the business development for CYPE Steel Products. And here you have my email address, which I will put in the chat. And you can send me any questions, anything you need to my email. But also, you can use the chat today to ask any questions. And if we can, we'll answer them today. But if not, we'll send you an email with the answer. For all of you that maybe saw us in the trade show in the NASCC, we did a workshop there, and it's gonna be what we did there. This presentation is gonna be the same, but if you missed it, you can see it today. So welcome. And oh, sorry. So I'm gonna leave you with my colleague David, and he is gonna show you all of these programs and the workflow. Yeah, so you will be able to see that we are a BIM company. We work in BIM.
Thank you very much for the lovely introduction, Marta. Now, without further ado, let's take a look at how this workflow would look like. I'm going to turn off my camera if you allow me. So the connect.
Sorry, before you start, we are going to, I'm going to switch off my camera just so everybody can see the whole screen.
Okay, so today we're going to take a look at the workflow that here we propose for steel structures from CYPE. And if you'd like to access all of the tools that I'm going to show you today, you can create a free account on BIMserver.center, which is our common data environment. You will see that it's a mix between an app store where you will be able to access all of our tools, which are under the structural analysis tab in here, as well as a project management tool where you can collaborate with multiple people at the same time in different projects like the ones that I'm showing you right now. So that way you could have a project made up of several work team members like this one. And those ones will be able to collaborate in real time by uploading and downloading contributions like the ones you're seeing right here. We are compatible with third-party software because we work with IFC files as our standard for transferring information between one software to the other. And of course, we even have a notification system built into this project management. So that way we can communicate with the rest of our colleagues in case we were to find out an issue with any of the elements that we may have uploaded previously. So going back to BIMserver.center here to the store, you'll see that in the structural analysis tab, we have a series of tools that are related to what we're going to show you today for steel structures. Namely, we have the portal frame generator, which is a sidekick to CYPE 3D, our general purpose 3D structural modeler. CypConnect, which allows you to design custom joints so you can analyze them with the help of the final element analysis engine, and Stream Steel, which will allow you to generate the steel detailing of your structure, not only joints, but also the general arrangement drawings, assembly drawings, parts drawings, and so on. So let's start, for example, with the portal frame generator. And as the name implies, this is a software that we produce. So if you're working with these kinds of framed structures, like for example, this warehouse that I'm showing you right here, you will be able to upload part of the design process to this tool before we switch into Site3D, that is. You'll see that we can set up the general data for this structure. That is, when we start a new project, we will be able to select what kind of truss we would like to use for our portal. Actually, let me generate here a new file so you get an idea. And you'll see that when we insert a new frame, we have the option to either work with mono pitch or dual pitch structures. And we have a series of pre-built roofs integrated into the software for things like rigid frames, as well as different kinds of trusses, like the ones that you can see right here. So it's just a matter of setting up the geometrical properties of your frame, and then the software will do the rest for us. So in this case, let's continue with the defaults, and let's take a look at how we can generate the stresses and the loads for our portal frame here. So once we have our portal frame, we will see that we can set up the building code as well as the loads that we're going to use for our structure. In this case, you would like to apply, for example, wind loads. You can see that we have many different building codes from around the world, and it's just a matter of selecting the wind load code that we're going to use, as well as some of the factors that we're going to use for the final analysis, like reference speed, terrain category, land orography, and so on. And the software will do the rest for us. Same thing applies, of course, for dead loads and live loads with things like, for example, roof claddings, as well as lateral wall claddings, which will be useful later when we design our purlins. Once we're done with the project general data, we can start inserting the lateral and roof purlins, as you will see here. And it's just a matter of setting up the analysis data that we're going to use. That is, things like the deflection limit, the number of spans that our purlin is going to go through, as well as the kind of attachment that we're going to use. That is, non-collaborating roof, quick fixing, or rigid fixing. And from then on, we'll be able to select the kind of purlin that we're going to design. We can set up two of these three variables, and the software will be able to size it accordingly to the third variable that we're going to leave up to it. So, for example, we can select the section type that we would like to use for our purlins, and we can work either with rolled steel, conform steel, or built-up sections like the ones that you're seeing here. And the software comes with a broad range of section series pre-built by default, as you can see here. You can even set up the layout data. That is, if you want to work with half section, cascaded, or web openings, lateral plates, and so on. And if you're missing the section series that you would like to work with, you can always work with some of the preloaded ones that we have in here. And of course, you can even create your very own if necessary. So in this case, I'm going to work, for example, with this section series. I'm going to separate them 1 meter between each other. I'm going to use this kind of steel So I'm going to design the purlinks according to the section type. And you will see that the software will cycle throughout all the different sections inside the section series. I will select the best fitted one for the loads that I have applied previously, both dead loads and live loads, as well as the wind loading that we have inserted with the wind load code. Like so. We could do the same, of course, for the burdens on the sides, and the process would be exactly the same. Once we're done with the burden analysis, we can export all of this data directly to CYPE, and from then on, we will be able to add the finishing touches, so to speak, for our structure. So let's switch to CYPE, which, as I mentioned before, is our general purpose structure analysis solution. And you can see that in CYPE.
David, just one question. Will you say that the portal frame generator is an assistant of CYPE?
Yes, that's the main purpose of the portal frame generator. That way you can offload part of the design process and you don't have to manually add all the loads and all the stresses linked to the loads that we've mentioned before, as well as the purlins, that is.
Okay, thank you.
So what you're seeing in here is basically the final result of exporting all of the data that we have modeled previously here in the portal frame generator. And here I've added the finishing touches, so to speak. Things like, for example, the bracing for the structure, as well as this upper floor that I've added in here, some of the beams that are going to fix together the rest of the portals and so on. And in CYPE, as you can see, we work freely in a 3D space with a nodes and bars based approach. We can set up our project so we can work with many different building codes from all around the world, including but not limited to things like, for example, the Euro code, the British standard, the American standard, and lots of other ones from all around the world, as you can see here. And once you select the building code that you would like to work with, you will see that the section series, as well as the reinforced concrete that we're going to use, is linked to the building code that we're going to work with. Also, we will be able to customize the load cases that we're going to use. And in this case, I've generated an additional load case for dead loads as well as live loads, which will be linked to the combinations that will be used according to the building code. So once I've set up the general data for my structure, you will see that we can start adding nodes and bars like the ones that we have in here. And for each one of them, we will have these helping lines, which will allow us to work faster when we are working with these kinds of FortiGate structures. And as I mentioned before, the other side of the modeling would be the bars. And for bars, you'll see that we can set up many different kinds of building materials, not only steel, that is rolled steel, built-up sections, and rolled steel, comfort steel, but we can also work with timber, aluminium, mass concrete, and we can even generate our very own custom generic sections if we're working with other kinds of materials. When we select the material that we would like to work with, you will see that we can work with a series of sections that come linked to it, just like we did before with the portal frame generator. And it's up to us to select which section series we would like to use. And then the section is going to be sized independently, automatically by the software. So it's a matter of setting up also the layout data that we're going to use, as we mentioned before, and the software will do the rest. In this case, I've already run the analysis for the structure, and you can see that I can carry out the section design, that is either as a quick section design or optimum section design, cycling throughout all the different sections of the series, or only using sections greater than the current one. And of course, I can also carry out the design of the connections, because in CYPE, we have a series of libraries for joints. So if you're working with standard joints series, like for example, the ones I'm showing you right now, the software will be more than enough. Of course, you will be able to customize all of these joints later. So in this case, I've already solved all the design connection with welded connections, but if I wanted to, I could also work with bolted connections as well. And when we're done with the analysis, you will see that we will be able to size accordingly all the elements according to the building codes, take a look at the checks that we've carried out internally as well, and of course, we will be able to take a look at the design that has been carried out for the joints. So you can see here that this is the joint that has been designed automatically by CYPE. But of course, if I want, I can always edit the properties of the different elements that make up this joint. Like in this case, you can see that I can change, for example, thickness of the base plate. Or if I want to, I can add stiffness to the size of my joint, like so. And of course, when we are done, we'll be able to take a look at the checks for this specific joint, as well as the detailing. You can see that the detailing contains all the relevant data for my jointing here, and this has been generated automatically by the software. Of course, this is not the only kind of design report that you can generate with Site3D, and actually you can generate a whole building report, so you can have all your reports as well as drawings containing all of this data. You can generate many different kinds of drawings as well with Site3D, including but not limited to things like the joints, like the ones that you've seen before, of course, as well as a simple general arrangement for the structure, as the foundation layout plans and floor plans, because we can also design very simple foundations with Site3D if we're working, for example, with pad footings and strap-on type beams like these ones. And I've already generated these drawings before, so let's take a look at the final result once I've exported it into a Didology drawing with a third-party software. So you can see that it's completely customizable later when we're working with CAD software, as you can see. The software has automatically set up the layout for all of my drawings, and you can see that it contains all the data that we were talking about before. Detailing for things like the layout plan for our foundations, as well as a very basic 3D general arrangement drawing like this one, and of course the detailing for the joints that we were talking about before. If you're working with simple structures like the one that we were working with before, perhaps the joints that we have built into Site3D are more than enough for you, but if you're working with complex structures, like for example this one that I've designed parametrically, as you can see here, perhaps the joints that you would like to design here need a greater level of customization. So in that case, what you can do is that you can export all of this data to a project on BIMserver.center, and you can reuse all the stresses and loads that we have designed in here, and you can send them to CyPE, which is the tool that we have for designing all of these kinds of custom joints, so we can analyze them later with a finite element analysis engine. All the checks that we are going to carry out inside CyPE will be according to the building codes I have mentioned before, including, of course, but not limited to the American Standard, British Standard, ERA code, and many others. And we can work with steel as well as with timber and concrete at the same time. You can see that we've been able to reuse the model that we've designed previously here in Site3D, and it's just a matter of carrying out the design of all of these joints, as you will see right now. I've already solved one of these connections before, so let's take a look at it so you can get a better idea of what we're talking about.
So just so people follow, sorry, David, we went from CYPE 3D, which is our designing and analyzing software, to CYPE Connect, which is for designing and analyzing steel connections and timber with concrete. But just so you know that we've moved from one program to the other. And you can extract shop drawings as well in CYPE Connect.
Okay, so let's continue with the modeling process in here. And as you can see, I've turned up all the operations I had carried out previously, so you can get an idea of how we could model this from start to finish. You can see that we start with an empty canvas, so to speak, and all of the different sections are clashing. And what we can do is that we can carry out things like adding, for example, end plates to end up with a non-clashing model like this one. This is not the only kind of operation that we can add, of course. And in CYPE Connect, we can work with things like anchors, stiffeners, as well as fixing elements for timber, as we mentioned before. And of course, we can also add things like bolts, welds, openings, blades, and so on. So in this case, what I've added, as I said, is that I've added in here a front plate to section V3, so it can connect to section V1 on its bottom flange. And we can customize any of the properties of this front plate. Like, for example, we can change the thickness of this front plate, like so. We can change also the overhang that we're going to use in this case. And if we have any other bounding elements, like that is besides the plate, the joint that we're going to design, we can also add bolts and welds automatically, or we can add them manually, which is what I'm going to do right now. So for example, you can see here that I'm adding some welds from the weld operation in here. And when we're adding welds, we can either work with lap, bolt, or fillet connection types, and you can see that we can customize the thickness of the throat that we're having here, as well as the initial and final displacements. This is interesting because later we will be able to carry out the rotational stiffness analysis for this joint in case we're not working with a completely fixed structure. And once we're done with the weld in here, we can continue perhaps with adjustments, and you can see that we can have things like section trims. I've added a couple of section trims here to section V2, and you can see that we can work either with straight, with chord radius, or with a drill trim. And I can set up also the properties for this trim as well, as we've done before. Now I'm going to continue with the joint between the interactions of section V1 and section V2, and for that I'm going to add a plate, which can be either attached to the webs or flanges of our section, or it can be set up freely in a 3D space. In this case, I'm going to work with an attached plate like this one. And as I said before, we can either add bolts manually one by one, which is what I've done in here, or we can use the bolt generator. So that way we can use the local axis of our plate to add rows and columns of bolts accordingly. We can also select the type and the material of the bolts that we're going to work with. And that's going to be taken into account when we carry out the analysis, of course. Once we've finished with the design of our model, we'll be able to export all of this data into a connections library, so we can reuse all the custom joints that we have generated previously in this project, as well as in future projects that we may develop. And what we're doing is that we are storing the operations that we have carried out here. So it doesn't matter if you're working with a different section from this section series. It doesn't matter if it's an IP 270 or a 300 or a 100, because what we are reusing is the operations that we have set out in here, and we will be able to customize them later, of course. So once we finish with the model, we can carry out the analysis of this joint. And if you are working with CYPE, you will be able to reuse the loads and the load cases that we've generated previously with CYPE. We can also set up the design options for our analysis, and we can get into the nitty-gritty details if we'd like to, for things like, for example, the digitization size of the element. And that's because we are going to generate a finite element analysis model off of the model that you're seeing in here, which is what I'm going to do right now by running here the stress strain analysis. We're going to turn all of these elements into finite elements, like, for example, we're going to turn the sections and the plates into shells, the welds into point elements, and the bolts into spring elements.
Sorry, just to add, we are using, as you can see, OpenSys as the engine to do the analysis. I just wanted to add that because it's important. Sorry, David.
Thank you, Marta. Indeed, we are working with OpenSys, which is the engine that we are using for our finite element analysis, and it's being developed by the University of California at Berkeley. And you can see that we can take a look at the final results of this analysis, either visually with things like maximum demand capacity ratios, as well as other kinds of graphs for things like formless stresses, deformations, and so on. I've run the stress strain analysis in here, but we could also take into account the rotational stiffness analysis or the buckling analysis for this joint as well. And of course, this is not the only kind of result that we can get from CYPE. We could either take a look at a summary report that we can generate with all the data for this analysis, which contains things like the components that we're going to use, as well as an abridged version of all the checks that we've carried out. And of course, we can even take a look at a full report with all the checks that we carried out according to the components-based method, alongside the finite element analysis that we've carried out, that is. You can see that we can generate a thorough step-by-step analysis showing all the checks according to the building code that we have selected. And all of these reports can be exported later into many formats like PDF, HTML, Word, and so on. Of course, this is not the only kind of output that we're going to work with in CYPE, and that is because we can also design the layout for our drawings as well. CYPE allows you to set up the drawings for your custom joint, and we would start with an empty canvas like this one, where we can insert automatically a series of predefined views of the BIM model. And from then on, we can work around all of these entities that we have in here. So we can populate our drawing with things like dimensions, of course, as well as smart tags, just to name a few. These smart tags will read the data off of the model that we have created previously. And if we were to update any of the properties of these elements, the tags that we're going to work with in here will be updated as well. So you can see that I can tag things like bolts, welds, plates, and so on. When I'm done, I will have something like this drawing right here. And as I mentioned, you will be able to export all of this data also into a PDF, DXF, DWG format, and so on. But you may be asking, how can I generate the full steel detailing, not only the joints like the ones that you've shown me in CYPE and CYPE, but for things like general arrangements as well as parts and assemblies? Well, if you already know how to use CYPE, Stream Steel works exactly the same. You can see that we can reuse the data from the structural model that we have generated with CYPE or with any other structural analysis modeler that is available in the market. And we can share all of this data, as I said before, with the help of BIMserver.center. So that way you can already have your model here waiting to be defined. As you can see, I've already done this previously with another job in here, and in Stream Steel we will be able to design the joints that we've seen before, not only for the steel detailing but also for the structural analysis, because Site Connect is integrated into Stream Steel as well. So if you already know how to use Site Connect, Stream Steel works exactly the same. So you can see here that we have some joints that we have designed previously, and the process is exactly the same as what we did before. We will be able to number our parts as well as generate different kinds of assemblies like these ones. And of course, we will be able to take this into account when we generate the output of the software. We can generate drawings that contain all of this data, which we'll be able to export later into the XF, geometries, PDFs, and so on. And as we mentioned before, this is not the only kind of output that we can generate with Stream Steel, but also we can work with DSTV and step files as well as IFC files as well. And you can see that with the software, we'll be able to generate detailings for parts like these ones, which you can see that the environment is quite similar to what we did before in Site Connect, as well as assemblies like these ones. Things like bills of materials, title blocks, and so on, as well as, of course, unions and the general arrangement drawings. When we're done, we'll be able to export all of that, just like we did before, into a PDF, the XF, or the .dot file format. Or, of course, if we wanted to, we can always export that into a DSTV or step file. Last but not least, we work in an open environment. So that means that if you want to relay all of this data back into BIMserver.center, you can just click here in the share button, and that way you will have an IVC EM11 compliant file that you will be able to transfer to your colleagues that are using our software or third-party software. That's the beauty of working in an open environment on BIMserver.center. You can see that you can take a look at the development of your project in real time at any time, like what we've done here. And of course, you can always use our apps, so you can carry BIMserver.center in your pocket with BIMserver.center Mobile. So you can also have augmented reality and virtual reality tools available as well. What we shown you today is just a brief introduction to all of the tools that we have for steel structures, that is design, analysis, and detailing. But of course, this is just the tip of the iceberg, as you can see. So I hope that this has been a pretty thorough introduction to what our steel solution is about. And I hope that I've been clear enough, and if you have any questions that we've been able to answer in the chat.
Thank you very much, David. It's been a really nice webinar. Thank you for showing us all these programs and the workflow. And if you have any questions, please contact me to marta.franca@cype.com. Let me put my camera again, sorry, so you can see me. So yeah, you can send me any questions to marta.franca@cype.com. And if there's anything that we couldn't answer in the chat, we'll send you an email with the reply, with the answer. So David, if you have anything to add.
Well, that would be it. Thank you very much for joining us today, and let's keep in touch.
Okay, Thank you very much, everyone. Bye.
Bye.